is fully overloaded.
Okay. If you don't hear me, that's okay. So let me welcome you at the first session of the spring term seminar, or Monday seminar. And it's my pleasure to welcome here one of our colleagues at UFA. And I'm really eager to know what everything can go wrong in live speech translation. So the floor is yours.
Thank you for the introduction. Well, I'm afraid that you will indeed see it live. As announced, this is a summary of the current status of the Eliter project, where we are trying to do live subtitling into many target languages. And I'll briefly describe how that works. I'll give it one more try. If there is anything appearing, no, it doesn't seem so. Oh yes, there is. Something is happening. So it is maybe at the bottom of the screen there will be English subtitles of what I'm saying. It is totally not certain. There can be many flaws in those transcripts, and deliberately we're not showing the translation because the translation has a hard time in fitting into these two lines. But if you have your machines, your notebooks, or maybe even cell phones with you, there is a shared Google document which you probably know from previous Monday seminars, and there is two links where you can see also the translations, not only the transcripts, and you can choose the target languages. I believe Hindi is also among the target languages. So there will be some intentional jokes during the presentation, and there will be many unintentional ones in the subtitles. Please don't laugh too loud. We know what is appearing there. But that's live, that's work in progress. So today I would like to briefly discuss the differences between machine translation and spoken language translation, and then I'll summarize the ambition that our project has. Because the ambition is high, we know it, we run a number of test sessions, and this is actually one of the test sessions as well. So after the summary of the test sessions that we are taking part in, I will briefly summarize the overall architecture, and then I will go along all the possible issues of all the everything that can go wrong. There is a long list of things that can go wrong. Luckily, thanks to the number of events that we are trying, this list of errors, the errors that we spot on every new seminar instance is not growing much. So we still have the errors, but luckily we are close to seeing known errors, which we have some ways, at least in some cases, which we have some ways to fix. Okay, and then I'll summarize and call to action. So again, tinyurl.com, Eliter Monday tests, that is where you can see the subtitles. Okay, we as the department have been working on machine translation for many years, or decades actually, and when we say machine translation, we mean text translation. And there the input are sentences which are almost always grammatically correct, and they may come in documents, so you may have some content, some context surrounding these sentences, or you may translate sentence by sentence, but it is definitely like sentence-based. In spoken language translation, the input is sound and the output is text. We'll get to some more details about what this text, but sentences may or may not be produced, and actually they sometimes should not be assumed at all. So maybe we all know that we do not speak in sentences, and figuring out where the sentence end is a difficult part. So that's there will be some tension when putting these two components together, the speech recognition and the machine translation. And there is one more area that I would like to just mention. It's called incremental machine translation, and this is machine translation researchers doing that. So they start with words that come in sentences, and they just feed the system with the words one at a time. So the incremental machine translation is still, at least to my knowledge, to my understanding, is still text-based translation. It just comes a word at a time. And that's different from the speech which comes a second at a time, like a bit of sound at a time. So the timing is different, even if we go for some incremental gene. Okay, so this is in pictures, the ambition or the summary of the two technologies that are examined by our project. We are trying to put together speech recognition and machine translation into spoken language translation. Here is some history of speech recognition. We haven't really, as a department, we haven't really worked on speech recognition. So I just copied this from somewhere, and it seems that already from the 80s, people run many shared tasks, and they improve the performance of the recognition. And here, around 2 to 4% of word error rate. That's where humans are with their precision. In early days, in 1990 something, some systems got to the human performance. Then on conversational speech, which is like unlimited speech or meetings, the systems are far from this benchmark. But that has been changing over the last years thanks to the neural networks. So the Switchboard conversational speech benchmark, that's 40 calls between two random English speakers. There, the human level of 6% has been kind of reached in 2017. So that seems like that speech recognition, if it's the right setting, can work equally well as humans do. Then this is the history of machine translation into Czech that you know from previous presentations of Martin Popel and also then from me. This is our systems, and the last one is the superhuman machine translation system from English into Czech. In 2018, Martin Popel's setup was able to outperform human translators, like professional translators, but that was bulk translation. It was they didn't pay more attention to that than to their normal job. So there was like the average professional translation quality, and evaluated sentence by sentence. The setup by Martin Popel was significantly better than that. Obviously, there is many caveats to take into account, but that's the setting. You have two technologies. You have spoken language translation, which could be on par with humans, and you have machine translation. You have speech recognition, which could be on par with humans, and machine translation, which could be on par with humans. So that is where we said, let's join them. Let's make use of these great two achievements. Let's put them together. So in our project, the Eliter project, we are trying. This will be badly misrecognized because it doesn't recognize any names. Well, so in the Eliter project, we are putting together speech recognition and machine translation in a highly multilingual setting. I'll mention that later on. Well, we are coordinating the project. The University of Edinburgh, including us, are experts in machine translation, so to say. Karlsruhe is expert in speech recognition. We have the top performing systems. If we put them together, I'm sure it will work great. And Pervoice is an Italian company. They have also been involved in a number of European projects before, and they were always in the role of the integrator, so they know how to put things together, and they have some baseline systems that we can build upon. And then we have a user partner, AlphaView, which is a remote conferencing system, where we would like to translate what people say in their remote calls. And we have another user partner, and that's the Supreme Audit Office of the Czech Republic. The Supreme Audit Office, they are too afraid of doing anything bad with financing, so they didn't want to get a single euro. So they are not part of the project, but they are just an affiliated user partner. So they are not supported by the European Commission. Okay, so the ambition. The ambition is very big. We want to support a congress that the Supreme Audit Office runs this year at the end of May or early June. And the participants of that congress come from many countries, and in some they speak 43 languages. So this is well beyond the capacity of simultaneous interpreting by humans, and we want to provide the missing languages, so to say. So there will be 6 languages spoken at that Congress. English and French and Spanish, German, Russian and Czech. These are the official languages of the Congress. These will be manually interpreted across so that all these 6 are provided, and we are to provide the remaining 43 the rest of the 43 languages. So this set of Eurosci languages is larger than the set of official EU languages, and that's also an important remark because many of these languages are much shorter of data. So the European Commission, so the European Union has already put considerable efforts into data sources. For some years, everything from the European Parliament was translated into all the languages. All the documents of the European Union are available in all the languages. So we have something to train on for these 24 languages, but less so for these 19 additional languages. And some of these languages have even brand new or unclear status that no grammar books were written for them yet. So that's a challenge on its own. Okay. So the events. We know that this all should run. So we have already started. The project has started last year in January, and in March we have added 1 extra dry run. So in our project plan we had like 2 dry run sessions and then the Congress. And we said, well, on the 3rd attempt to do everything well, so that the 200 delegates or 400 if you count the delegate and their fellow, the 400 people will see what we have tested just twice beforehand. That's impossible. So we have added a number of other events. The first one happened in March last year. It was a student fair of fake firms like mock business companies, and there we were testing the old and pre-existing technology, what Karlsruhe had and what Pervoiz had, and we just added our machine translation system from English into Czech. Then we also got in touch with I don't know the correct English name of the department, but the Department for Interpreting and Translation at the Faculty of Arts of our university. And thanks to their support, we are able to attend their mock conferences where the interpreters are getting trained. And we are recording these multiple interpreters and like seeing what our systems can do with that multiple input. So this is like similar setting where there is interpreters in the booths, and we are trying to follow what they are saying and complement it with the other languages. And then we had the 2 official events that were planned for our project. That one was a working group on value-added tax, which happened in June, and then right after the summer in October there was another meeting. So these 2 events were like quite close to each other. So not much the development was possible between these 2 events. And then in November we also added one more. I was showing this technology in a little demo on the Matfis Open Doors Day, and I was also trying to present it at Best of Prague AI event. And then in February, so very recently, we had a workshop, a dry run of a workshop, which will also run at the Congress. And there, the purpose of the workshop is to demonstrate not only machine translation, but all other text processing or NLP technologies to the audience, to the lay users, the supreme auditors, to illustrate how the NLP tools can help them in their business. And we are going to run this workshop obviously in English, and there will be the language barrier, so the auditors would like to see some translations of that. So the successful demo was only in November. This was a big failure because the Wi-Fi didn't start. I'll mention that later on. And then at the LangTools workshop, everything worked well, but it was actually still pretty useless for the users. And hopefully you'll see in the following slides why this is the case. This is the upcoming events. There is again the mock conferences at Faculty of Arts. We will again try to see them. There is another instance of the Student Films Fair. We are again trying to get to that because the high school students from across the Europe provide beautifully non-native speech. So they are very hard to understand for the ASR system. So we gather test sets there, and we are making it a shared task to understand these high school students. Yes, so this is the shared task where we are trying to get also other research institutes to process that data, the high school students. And then we will have a second dry run of our workshop. Maybe we will add some other things. And the main event is early June here in Prague. And there are all the Monday seminars. So again, at every Monday seminar, you will have a chance to see these subtitles. Okay, so here is a very brief report on last March event, the Student Films Fair. There was one speaker also that like we put the mic to, not only the students, Tomáš Sedláček, the Czech economist. And you see that the old system worked pretty well, including our Czech translation. So he was speaking, and it was recognizing him, it was recognizing sentences. So for about a minute, we had a perfect show, and that was it. From 3 days, we had like 1 minute. So we started blogging, and we blog about all our successes on our webpage. Blogging is fun. So with blogging, you immediately feel famous. It doesn't really matter if anyone follows you. It's just the fact that you posted somewhere that makes you feel famous. And you can also sometimes improve the reality a bit. Well, we do not do photoshopping of our demos. The only thing what we do is we select the bits where it worked. From those 2-day events, it was 1 minute, but we are growing bigger. So hopefully there will be almost 50 minutes of today, which will be subtitled throughout the whole session. So I said at the beginning, ASR and MT, these are perfect technologies, they work very well, they are superhuman, you just plug them together. Well, it's not quite like that. You still need to acquire the sound, you need to get the input, and you need to present the output. And there is also the little clash. The speech recognition recognizes words, but we are ready to translate sentences. So what you need to do is you need to segment that stream of words into sentences, and only then you can translate them. So that actually still requires you to add one more component, some segmentation worker, and you also need to ship all these bits of stream to the various workers along the pipeline. So the two steps, just put the two steps together, setup is actually this complicated. So this is the overall architecture. It's built upon something which Pervoice developed in the previous projects. It's called the Pervoice platform, and these components, all these components, the speech recognition and all that, connect to a central point called the mediator, and you have a client. That client connects to that mediator. The mediator ships it to the ASR, then to sentence segmenter, then to machine translation, and then to presentation, and the presentation delivers it to the web. We just received like a confirmation that this single word, this second of sound, was processed along the whole pipeline. So this runs across the Europe. So some of these components run here in this building, some of them run somewhere in the cloud of Pervoice, some run in Edinburgh, some run in Karlsruhe. So that's is distributed. The connections are always open and they are reused across the clients, but it uses one particular type of internet communication, the TCP protocol, and that requires that the network is very broad in the connection, so that it doesn't collect any delay, any lag. This is the setup that also includes the wiring. So you need to like connect the machines to the microphones and connect the presenting system to the screen and all that. And this is the setup for the Eurosci Congress, where there is 6 interpreters booths in all the 6 languages that humans interpret into, and then we are collecting all those and choosing which one of them to translate from, and then translate to all the remaining 30-something languages. So the setups are complicated. This is the workers connected to the mediator platform, and you see that some of them are busy and some of them are available. So this is like a big infrastructure. So let's start with some of the issues. Obviously, the network can slow things down. So once we faced the fact that in Karlsruhe there was some construction or whatever, for some reason the university had a little slower internet access. And that delayed all our processing. So immediately we were not live, but we were like seconds or dozens of seconds later than the signal. So you should be actually on stage or very close to the venue if you want to deliver simultaneous speech reliably. For a test, this is not a problem. But if you want to do it live, you should not rely on the internet. This was the problem at the Best of Prague AI session, where I have tested everything. It worked perfectly for the demo. Unfortunately, even like I've asked a month beforehand, and then for the second time, I was not allowed to connect my machine to a wired connection. I had to rely on Wi-Fi. And everything worked twice when I was at the venue. I tested it. Then the audience came, and the audience brought their cell phones. Nobody actually used the internet. The cell phones were just trying to like look around, is there any internet available, and they tried to connect, and maybe just these tests simply killed the Wi-Fi, and it didn't work for me at all. So nothing was ever recognized at that event for me. So we must not rely on wireless connection. Then we also had issues where everything went well, except the final presentation was like filling buffers of web browsers. So it was not showing properly on the end user devices. Everything was okay until the final presentation point. And this is like a misconfiguration error. Like if you are juggling with the setups, it's easy to make a mistake. So in one of the sessions, we were observing some horrible delay gaining or growing. And the reason was that we ran our own ASR system, because we are also experimenting with that, and we ran it locally. But accidentally, we were first sending the sound over Wi-Fi to Italy, and then sending it back to our place to recognize it, and only then we were recognizing it. So this double network load has caused the delay. Next time we like recognize it on the spot, and the problem was gone. Okay, now sound acquisition. You may recognize some of one of our colleagues here, and the problem is if you have this microphone, the chest microphone, and you put it here, and then you talk to the slides like that, the microphone doesn't really get your voice. So that's one problem. This is another thing. Right now, unfortunately, we had to switch off this chest mic, and I'm relying on this mouth mic. We wanted to extend this test. So based on 3 minutes of testing, the error in recognizing English and Czech is several points lower if you use the mouth microphone compared to the chest microphone. So that's just the distance from the mouth and the movement of the head that makes a measurable difference. So we are relying on the better on the head microphone. Yeah, this is tips for singers, for vocalists. You have to hold the mic properly. You must not put it in your mouth almost. You must not put it too far away from your mouth. And also, if you stand in front of the loudspeakers, the reverberations will totally kill the signal that you're receiving through the mic. So this is what has happened to us during the student film fairs, when the students were just roaming around, and they entered the area in front of the loudspeakers, and suddenly there was no way to recognize them. Okay. Then there is cables. You have to plug the cables properly. And one of the settings in the conferencing room for the interpreters, we were able to get the signal only when one of the connectors here was not fully plugged in. The reason is that we were like misusing the connections. So once we brought a proper sound card, it was able to recognize which pin of that connector has what. But without the proper sound card, with just the built-in sound card of a standard notebook, you have to like misalign the pins on of that connector to get the signal. So that was an hour or two of debugging until we figured out how to connect the input. So that's we're learning. So then there is the volume setting along the pipeline. If you have a wireless microphone, it has a receiver, and there is a volume control at the receiver. And then you have a sound card, and that also has some volume control, and it also has some button, like two buttons. So line level or mic level, that's one button, and padding on or off. So you have to, that's like 4 options at least, just for the buttons, and then for the knobs. And you have to set this properly. Otherwise, the sound can be too quiet, or the sound will be too high. The volume will be too high, and someone along the pipeline will clip it, and then you don't get the frequencies, and the ASR will not work. So you need to carefully track the signal step by step. Experienced people know. I remember the colleague from the Pairvoice company who came for the student fairs for the first time, and there we still were struggling with getting the signal right, and he like followed from the mic with the headphones. He always connected his headphones and then said, okay, it's good here, and step by step he managed to deliver the right volume to the machine. So that's, you have to do it stepwise, and it can fail at any point. So then ASR quality. So once you have delivered the best possible signal, what does the machine recognize from that? So this is an example from the high school students. The speaker wanted to say something like, "You have a bottle? Oh yes, we're situated in the heart of České Budějovice." But in reality, this is a high school student. So he said, "You have a bottle? Oh yes, we are situated in the heart of České Budějovice." So there was serious mispronunciation. And there was also high level of background noise, because that's a fair. So there is stands with music playing, and we are just behind a little wall, hoping to get some shelter from all that noise. So if you are a person and you are in these hard conditions, then you will probably understand something like, you have a bottle, because you are not expecting the student to talk about a hotel on the boat. Oh yes, we're situated in the heart of, and then he would recognize that some city is being mentioned, but if he is from Spain, he would not know that České Budějovice is a Czech city. The standard ASR would deliver something like, oh yes, the of, and that's the few words the ASR can spot in the noise signal. If the ASR is noise resistant, if it can somehow cancel the noise, then it will do something. You have somebody too. Oh yes, we are situated in heart, which is can we do, because it doesn't know the name of the Czech city. And if we have a future ASR or a person in the middle, actually, then we would get the proper recognition of that sentence. So this is all the problems that we are facing when we are trying to transcribe non-native speakers. This is a summary across the recordings that we made there. So remember, the word error rate for humans is around 6 or 4%. Here the Google system, Google ASR, had error rate of 9-ish. Edinburgh system also, and Karlsruhe system was actually the best one, around 40. Still 10 times worse than what the humans do. And this is on the recordings where all the systems have produced any output whatsoever. If we apply, if we plot the same figures, but we count 100% of errors as the score if no output is delivered. Then Google is much worse than Edinburgh. So Edinburgh was better, was not like giving up so frequently, and Karlsruhe is still the best system. But still, the Karlsruhe system is 10 times worse than the humans, and that's then what is reported in the literature. Obviously, this is hard conditions. So this is background noise, non-native speakers. Well, we were not yet quite professional in the recording, so we just misaligned the mics, and people like spoke too loud, and we didn't twist the knobs properly. So it is very hard conditions. But this is the reality that you can get. So this is the best recording according to the ASR quality. And there are things like, why do you wear those high heels instead? Why do you wear those high heels? And deals. Yeah, there is. I know of one really good star instead of a store that deals with the sale of free down food instead of free time footwear or something like that. So it's totally wrong. Okay, so what is our plan given this? So we are definitely going to retrain our ASR models, and ideally we would like to use non-native speech corpora. Common Voice by Mozilla is one of these that can help. And we have another fallback thing to do. We would like to follow interpreters instead of the floor, because each of the interpreters will sit in a booth with limited noise from surroundings, with better microphone. So we have more control of the recording. We can also talk to the interpreters and explain to them that they are being recorded and processed in particular way. And we also have the chance to adapt to them. So we are trying to get their contacts. We have still a few months to come. And even if they are non-native, we should be able to adapt to their particular speech. So we would ask them to do well, a few minutes, possibly up to an hour of recording. We would pay them to whatever, read some text or interpret something, and then we would create a training data set for that particular person. And then obviously we are going to gather in-domain data, test set, and regularly evaluate. So that's the ASR. We get the text. So what do we expect now with the translation? There are all the standard translation errors that you know very well. So here's one example. A sentence which was actually recognized perfectly. I know which sentences are recognized perfectly, so I know what to avoid when I'm running a demo. This is also different from the users of our system. They will simply speak as they are used to. If I want to showcase what our system is doing, I will avoid named entities, I will avoid strange constructions, I will have like fluent newspaper-like style of sentences, and then all the systems will successfully recognize me. So this is one of the cases, but it is much more difficult to ask if you do not have any clue. And yet the translations both into German and Czech, two sample languages, were wrong. The if was translated as op or zda, and that like distorts the sense of that. So my guess is that maybe in English you would, in a native English, you would actually say this a little bit differently, and then there might be a more explicit clue in the source sentence. I'm not saying that the sentence in English is wrong. I'm saying that in the training data, which is news or maybe books or EU legislation, there is this slight domain mismatch, and even if it's not a domain mismatch, this is a genuinely ambiguous conjunction, and it is difficult for the machine to guess the meaning. So if you are closer to the training data, then it will work better. If it's difficult, an ambiguous expression, you will have these problems till like forever. Yeah, here is some just misunderstanding, or it was out of vocabulary. The machine translation system ran out of vocabulary. You can be reported after some profanities. So if you say something bad on your website, then they will like block you. And that was mistranslated as professional things. That's because the profanities were not in the vocabulary of the machine translation system, so it resorted to subword expressions. Okay. The problem in spoken language translation is that the ASR errors get kind of multiplied in machine translation. If you have an error in speech recognition, then the error will be a few edits, a single word similar in shape to what I've said. But then you take this single word and you translate it, and then the shape of the word totally changes. So machine translation takes all the wrong words from the ASR as fully trustworthy, and it happily reorders the sentence to make it the best possible sentence, including those wrong words. And there is no information about the confidence, neither from the ASR system nor from the machine translation system. So the user will be just left with a sentence which sounds perfectly natural, but mentions some strange entities which were never mentioned, never part of the talk, because they come from an error. So here's an example, and the goal of my thesis is twofold. That was twofold. So instead of twofold, the ASR recognizes twofold. That's a natural misrecognition. The empty output was, and the goal of my theory, instead of thesis, is to fall apart. So that's definitely not what we were after in the system. Yeah. So this is what I would probably translate it to if I was to translating it. But I just wanted to highlight that this twofold, misrecognized as twofold, was translated as rozdrobice, to fall apart. And that's totally out of the scope. Okay, so what do we have? What is our plan for the machine translation? Data, and then maybe a little bit of modals. So we are definitely going to gather more parallel data. University of Edinburgh is working on that. We're going to gather more target-side monolingual data and backtranslate. That's for the domain adaptation. So this is auditing domain. So we would like to focus on all these materials. They are hardly parallel. Some of them are, but not too many, and especially not for those 19 non-EU languages that we are also aiming at. So hopefully our baseline systems in the back translation will make some sensible output from that, and hopefully we'll be able to improve the translation quality. We will create in-domain test sets, and we will regularly evaluate on them. We'll also try to get in touch with TAUS again. That's a collection of user-supplied parallel data, and they can, given our test sets, they can extract the most similar sentences. So some filtering of larger pool of parallel data. We will also try to create gazetteers, so list of relevant named entities like participants or the presidents of the Supreme Audit Offices. This is having just a list of names. Is not ideal for machine translation, but it's definitely better than nothing. So we'll try this as well. I'm also considering, and this is something that maybe someone of you could try, I'm considering to train machine translation on distorted source, because I would prefer the machine translation system to say something in the domain and sensible, rather than to try to perfectly translate the wrong ASR output. So for me, tentatively I'm saying that, it seems to be better to say something similar or related, rather than do a perfect translation of the wrong input. We'll see whether this is a good assumption or not. If the system starts making up the content, then obviously the users will not be happy as well. But right now, our system is too easy it's too easy to notice that our system is doing something wrong, and we want to hide it a bit under the carpet. So let's see if this will be a good strategy or not, and let's see if we manage to train such a model. And I'm afraid that we will never get, during this few months, to the interesting things like the speaker's gender. Obviously, the machine translation system has no information about the gender of the speech. The parallel data is totally non-labeled. It doesn't know about that fact either. And English doesn't mark most sentences for the gender of the speaker. So it's very likely that our system will be just making up and switching the gender of the speaker in the first person sentences, and that will be very confusing for the audience. So I'm afraid that we will not get to this unless there is someone who would like to help. Okay, then the integration of the ASR and empty. I've already said ASR emits strings of lowercase words. Machine translation expects individual correct sentences. So there are a number of options that we can try to bridge the gap. So we can try to insert punctuation into the ASR output, which we call the segmenter, or we can change the ASR to predict directly correct punctuation. So the speech recognition would run not into just sequence of words, but sequence of words with punctuation and capitalization. And a student of mine is working on this, and we can also try something which is one of the research goals of our project, that's fully end-to-end spoken language translation with one neural system that gets the sound in one language and produces the translation in the target language right away. So that's again part of Peter's thesis. So the segmenter, given a stream of words, gets punctuation casing. We use AutoCAR still tool, so someone's tool. Unfortunately, the speech information is no longer accessible to this tool. So it has just the sequence of words, and based on the sequence of words, it is guessing sentence boundaries. And as one of my colleagues from the room, a discourse specialist, said, it's actually doing a very good job, given that it doesn't have any information about the pauses, about the intonation. So it's surprising how well it can predict the sentence boundaries with this poor information. Still it is far from perfect. So there are many errors. There is also another tool which would consider the intonation and delays, but we haven't had time to integrate it. So if someone would like to play around with that, we would be happy to get any help there. So Sangeet Sagar has trained this segmenter tool on Cheng data, about 4 million sentences, and here is the precisions and recalls for various punctuation marks that we are inserting, and highlighting the recall of period, because that is critical to identify sentence boundaries. It's 70 to 80%, which is reasonable if you look at it as a number, but it is still far from sufficient for practical use. Okay. So here is an example of an error in the segmentation. So errors in precision lead to confusing empty output. So here the speaker said something like "all too well." That was part of a longer phrase, and the ASR plus segmenter put a full stop between this, like in the middle of this phrase, leading to the output: "This approach does not generalize all too," and then separate sentence, "well, so to somehow conclude the whole talk." So here the semantics is obviously changed quite a bit. This is exactly the case where the machine translation would one by one receive the first sentence and then the second sentence, and it would have no way to recover from the full stop, which should not be there in the first place. So there the two sentences would get like beautiful, but the message would be distorted. Errors in recall make too much content unstable, and we'll explain this on the following slides. So here's another technical thing, the messaging between the speech recognition and spoken language translation. So if it's the online speech recognition, we are receiving text messages, but these text messages of strings of words are not related to sentence boundaries. So in the first run, and this is what we were mostly seeing in March or at all the sessions that were the tests for the Supreme Audit Office, we were receiving these messages. So this is the first message, the second message, third message, and fourth message, and we were directly sending these messages to the machine translation. So the first message was, "You should think there have," and that's still unfinished sentence. Machine translation system, given this input, decided to totally omit the first sentence because the first sentence doesn't fit there. The machine translation system is trained to translate full sentence into full sentence. So some half a sentence here, let's drop it. So it said just děkuji, thank you. And then this is an extension of that message. So the ASR sent again the same prefix, and then it added the extra words that came in the meantime. This is probably the best translation that the MT could have delivered for that. And then the ASR sends something which we call the confirmation message. So the ASR says, well, I will not bother with these 3 words anymore. You should thank. I'm finalizing these. And from now on, I will only send you the rest. There have been many revolutions. So here is a single message. You should thank. So that's one complete sentence and a beginning of another sentence. And we have translated it as if it was one sentence. That's just wrong. And then the next message starts in the middle of the sentence already, and we are again feeding it as if it was a complete sentence. So there is like the sentence boundaries are totally unobserved by our approach, and that kills everything. It emits, it upgrades all of these partial sentences into full sentences, but that's not related to to what the people said. Okay, so if you put together the ASR and MT better, and we did it, and I'll show you on the following slides, then you still need to present somehow the result. So we're slowly coming towards the final stage, and still it can totally kill the show. If you have a font too small, such as in the subtitles, if they were a little bit smaller, they will not be of any use for you at all. So you need to very carefully balance like how much content you put somewhere, and if the font would be legible, if it's legible for people in the first row and for the people in the last row. If they have to rely on the cell phone, then suddenly they have a different shape, a different rectangular area where the translations and transcriptions appear, and this heavily affects how much information we can send to them, and we have to dynamically decide what to send to them and what not. For example, then if this text flickers too much, if the words change too quickly, you cannot read them. So that is one of the reasons why we have not employed the fully neural network ASR system so far, because they are trained to operate on a window that moves in time. 8 seconds at one go are always recognized, and the beginning can change. So imagine 8 seconds of my speech back and still like redeciding what is the first word. Mostly the words do not change, but sometimes they do. And if you have this long piece of text and it like swaps here and there and back on various places in various words, you do not know how to follow that. It's like unstable text. So we are working on this integration, and I wanted to highlight that this presentation must be tested on stage. You cannot test it in simulation. Like the sizing of the text, the visibility from various areas, that all can kill it, can negatively affect it in such a way that it's not usable at all. If you have ever ordered something from an e-shop and it came, but it was like the wrong size, either too small or too big, then you know what I'm talking about. If in an e-shop you have a picture of what you are buying, but the picture is out of proportion, you don't know if you're getting this big teddy bear or this tiny teddy bear. So it can be of a wrong size, and that's the same thing as here for the subtitles. So here's one of the views that maybe you have been watching on your machines. This is mainly for showcasing that we can run the translation into many target languages. So we are showing 2 lines of subtitles in 10 languages at the moment, and this will be 43. This is good to demonstrate that the system is following me, and it can create a falsely positive impression. Because if you are following me and if you understand my language, then you can no longer read carefully what is in the subtitles, and you will only observe the right keywords there. So if I say something about subtitles, and you will see titulky in Czech, then you will notice, oh great, the system is recognizing this person. But you are not able to judge the quality of the sentences. So the sentences, in fact, are pretty crappy, and they jump too quickly. And if you did not understand me, and you only had these 2 lines to follow, then you would get lost in the errors of ASR and MT. So this is good to show off, but it's bad for the user. So we have something else. We also show much longer context, the text as it grows. And here you have, I don't know if this was probably given in English, and then it was translated into Czech and German. And here you already see the difference between the stable output, the partial output, and the incoming output. So some of the sentences are fully processed by all the components in the pipeline, and there is no way they could be updated any longer. And these sentences are shown in black. And then there are sentences which are gradually being updated, and here still the punctuation can like make a difference. So that's why we are showing this only in gray. And then there is the last sentence, which is still getting more and more words. And as the segmenter finishes processing of some of this, then some full stop here will appear, and it will be out of the processing area of the segmenter anymore, and it will become the black and fully stable output. Here you see why the full stop recall is important. If the full stop are too scarce, they are too infrequent in the output, then too much of text will remain in this gray phase, and too much of text will be still undecided and flicker, and people will wait too long for the stable output. And it's also like a matter of taste, whether people would like to follow the more unstable, more recent output, or whether they would like to follow only the stable one but be several seconds behind the speaker. So that differs. So this is something that we have to update, and ideally it would be the user's choice. Would you like to have the shortest possible delay at the risk of reading something which will be still like fixed, or would you like to wait a little longer until our output is stable? So that's something that ideally the user would choose. So if people are provided with this longer context, then they can better recover from errors along the pipeline. So it is almost possible to follow the content of a talk which is not known to you, if it's not too far from the domain of the training of the machine translation system. So here is a little summary of what has to be done if you are presenting text only in the 2 lines of subtitling. So you have some ASR, so this is some English stream of words, pixels on your screen at any given moment. It is also very flexible architecture of this is an entire book. So you see that there is no sentence boundaries, and the segmenter needs to predict some sentence boundaries, so it predicted a full stop here and a full stop here. And then some ASR update comes, and it also, based on this update, the segmenter has another update, so it predicts one more full stop here. So this is like sequences of updates coming, and some of these sentences are already completed, so the segmenter says this full stop is final, I will never take it back, do with this sentence whatever you like, I will not touch it. Then some of these full stops are still unstable, so I may remove this full stop and I may move it slightly, and then we also have to handle that properly. And then yes, and the rest, the last sentence is only expected or incoming. We don't know what the sentence will finish like. We are sending now full sentences to the machine translation system. So that's like good. That means that the empty system is fed with the input it is ready for. So now going into German, it will say something like Pixeln auf Ihrem Bildschirm zu jedem Zeitpunkt. Es ist auch eine sehr flexible Architektur. So this makes sense. This is like correct German sentences. The issue is how much space you have to show this German to the user. So if we have 2 lines of subtitles, then we would show this yellow part and this yellow part. And then because the last sentence got some extra words, it got extended, the system decided to change the beginning of this sentence. It decided to change the last word on the first subtitle line. If the line is still visible, we can easily do the change and nothing bad happens. if we are limited to just one line of subtitle output, then this line has been already rolled out. Like the user can no longer see it. The user saw it a second ago, but now this is no longer accessible. So we would have to show like only half of the sentence, and that's something that we cannot do. So the sentence has changed. We call this a reset. Now the subtitling mechanism has to go back and show something which has already scrolled up and show it again so that the user can reread. But this reset is extremely annoying. So you may have noticed that sometimes these subtitles got red. And the red effect is exactly highlighting a reset has happened. So the segmenter was oscillating, like where to put some of the full stops and where to put the casing changes. And if the change of the full stop or the casing happened above that in a line which already rolled up, then the subtitling, even for ASR, issued a reset, and it also indicated it in red. So the red for me was like a remark. Yes, this is a red. This is the case where the subtitles had to scroll back because something was updated outside of the screen. So that is an illustration why the limited output space is so critical for delivering the translation to the user. If you limit yourself too much, if the language difference is too big, it's the word reordering and the length of the sentences like make you redo larger bits that then fit on the final screen, then the user will be experiencing very confusing resets. I'm like stressing this because this is something, these are decisions that you make along the whole pipeline, and it's only the very last bit, the size of the window, that kills it or makes it workable. So that's why we're like fighting in the consortium, like what is the better output. It seems, based on these arguments, that you definitely do not want to have these subtitles. You should prefer the longer paragraph view that you saw on the previous slide. But the problem here is that if you make some very bad mistake, if some bad word, some profanity appears in the output, it will stick there for too long, and people will like take out their cell phones and take pictures of that bad word. So you are exposing too much of your problems in this setup. So that's why some partners in the consortium prefer the subtitles, but there is the big risk of the subtitles being incomprehensible. Okay, so then there is the overall cognitive load and the overall usability. We have two users, they are here, who confirmed that, there's many, that's another, these are these. So there's, many users who have tried to follow this have said that there is no way that you would be following the translation on your notebook and looking at the slides or the speaker who is in front of you. Even if it's like in a very close angle, if you do not have to move your eyes too much, you still have to accommodate because of the different distance, and that will take some time, and then you will, as soon as you look up at the slides, you will lose the subtitles and you will lose content. So we are now working on adding the slides also to the screen where the subtitles appear, or the other way around, putting subtitles to the screen where the slides are. So this is something which has to be done. And then the overall usability. The overall usability is still very bad. Well, I'm inviting you, whoever doesn't speak French and would like to join us. We are, hopefully this week, we are running like French movie watching session, or just 10 minutes of a TED Talk. We don't speak French, so we will follow our systems, recognizing the French and translating into English or Czech or any other language. And we will try to come up with improvements that would make it actually usable, because it's very big difference whether you can understand the source language or not. We had a similar session with Martin Popel presenting something on machine translation evaluation in Czech, and it was attended by our 2 foreign students, and these 2 foreign students reported that they could follow the Czech talk if they fully focused on the paragraph view. And as soon as they looked up on the slides, they got lost. So if with full attention to the slides, it was possible to follow it. But this is not for normal users. Like normal users have to have some free time for their brains as well. I would like to highlight that the desired setting differs from user to user. Those who understand the source language will need the simultaneity, and they will prefer it over precision and stability. If you are following what I'm saying, then and if you are reading the subtitles in your mother tongue, then they could provide you with words that you missed. If you do not understand a word, it could appear here, you would understand it. But it has to appear there on the spot, at the moment when I said the word. If it's there 3 seconds after, then it was of no use to you anymore, because you have moved in what you're listening already. So if you are following the source language, the subtitles in your mother tongue can help you, but they have to be immediate. If you do not understand the source language, then you are only relying on the text, and in that case, you would prefer stability and precision, and you are happy to wait for seconds. You don't know what I'm talking about at all. So it's not a problem if you get my message 8 seconds later. So this is two very different use cases, and it should be the user who selects which of the displays is there, not us. Okay, so the evaluation, there are 3 aspects of spoken language translation. Quality, that's something that we know from machine translation, and we know how to vaguely estimate the translation quality. But there is also the lag, how much is the text in the translation delayed behind the source. Some of the lag is obviously inevitable because you have to wait for the German verb, or you have to anticipate it in some way. And there is flicker, so if you have a system which is updating, and we have such systems, then these systems can anticipate, and they have the capacity to correct themselves. So then suddenly they can create some output and then remove it in the next step. And this has to be controlled very much so that the user is not confused. So we're working on an evaluation tool with Ibrahim Ansari, and here is just the most serious problem. If you have this English ASR, do you know it's a cat? Isn't it? Yes, it is like that. So let's imagine that the segmenter has segmented it into these 2 chunks. There is no way to align it well with this German translation reference, because it has 3 sentences that the words are grouped in a different way in the sentences. So we have to somehow force align these so that the basic set of units that we are evaluating over is common to all systems, regardless of what the English ASR does. Everybody has to reach the same reference segmentation. So there is some strategies. I'm not going into the details anymore. Essentially, we have either the option to work with these sentences and consider more sentences at the same time, or we can totally forget sentences, and we can evaluate by evaluating 30 seconds chunks. So did the SLT pipeline produce the right words within these 30 seconds? And if it did, then yes. If not, then not. So this is like a way to go around the problems of sentences not being uttered in speech at all. Yeah. So the surge, or the mobilization, as I say it, the battle towards a usable system is still not lost. So we are now building an army of paid volunteers, and if you have any colleagues or students who can help us between now and May or June, we are totally happy to take them on board. We are meeting at least once a week for just 30 minutes and discussing who is working on what, and we have funds for this, so this is like paid work, and you can do many smallish tasks. For example, if you are looking at some of the empty outputs, there could have been bad characters because no one has yet checked where they come from in the pipeline. Then there is larger things that we need to develop. We would like to have a dashboard which we will give a configuration, like a live system running, which grows log files, and this dashboard should allow us to immediately see where is the problem. So for example, if we are recognizing the English booth with the French ASR, then there will be many French words coming from that systems, but they will be totally wrong. That's the most laughable output I have seen so far, like swapping the languages for the ASR, because the systems will struggle. It will be like words similar with pronunciation, but in the wrong language, and the sentences won't make any sense whatsoever. So this can easily happen. If you are following 6 inputs and translating into 43 languages, you need a concise view to know what your systems are doing. So that would be a dashboard. Then a lot of work on the domain and speaker adaptation, just getting in touch with all the interpreters who will be in the booth and contacting them, asking them to come here, record an hour each, and then using this data to adapt the system. Again, a lot of little work. Code switching is something which I have not discussed in my talk at all, but I'm realizing how frequent it is. Not only in linguistic lectures, where we have examples in 4 languages, but also native speakers of other languages than English frequently bring in English phrases, and the ASR systems are totally not ready for that. Then it's very similar to named expression or named entities. It's simply unknown words that get recognized into something very bad, and then when this gets translated, it's very laughable. There is also another activity which I would really like to start. I call it ladder climbing. So it's when you have a fixed test set and you are working on improvements of your model or the pipeline. So you are making many small changes, and you are always evaluating on the test set. So you are climbing the ladder of performance. So this is what we have to run. I'm hoping for like 2 bigger model retrainings until May, and many architectural changes, many like smaller fixes that can improve the score quite a bit. And I've already talked about this dashboard, but it's still something different. The dashboard is like technical setup. You want to know that the sound volume from all the 6 inputs is the right. With this multi-source monitor, you assume that technically the architecture is all set up well, but still you need to decide which of the ASR in the combination with the speaker works best, and which of these sources delivers the best translation quality into the many target languages. So this is like technical check that everything is running, and this is selection of the best path for the best the output quality. To summarize, Eliter subtitling is a big challenge for the project. Even if you connect 2 superhuman components, they can still deliver crap together. So we are now working on making this usable. Technically, the complex pipeline now works. It has been working. How many restarts did you have to do, Sangeet? Multiple. Okay, so it is not seamless, but with one operator, it can survive 60 minutes of speech. But unfortunately, even with this whole system working, the benefit for the end user is still limited or non-existent. So if you didn't follow my English speech, if you only had a chance to read the Czech translation, I'm curious how much you would get. So this is one of the, we have still a few months to go. I'm very lucky that we have these months to fix the pipeline. And some of the problems that we are running into are not going to be solved in the next 2, 3, 5 years. But some of them can be fixed. So we'll do our best to make the output actually usable. Please join us because that's it. So we have a technology which technically works, but it's totally unusable, and I'm curious how far we get in these months. So we are running this army or this mobilization. So we seek for your help and just talk to any of us. So maybe those of you who are already on the search team, just raise your hands so that people see. 1, 2, 3. So yeah, Atul. So at least four people in the room already. And if you have more, or if you have students who would like to get in touch with this is a nice. It's not a summer internship. It's like spring internship. Please let them know. And you can read all the details about our project in the blog. And if you want the real truth, then talk to us directly. Yeah. Okay. Thank you.
I think we still have some minutes to ask questions or add some details. Yeah, Hanka.
Well, you spoke about the problems from ASR if there is a mistake in understanding of the word, and it brings the problem further to the machine translation. And you also spoke about the module that puts the punctuation into the stream of words. Did you consider something like some sort of grammar checker or some language model that would check whether the supposed sentences are really sentences or grammatically good enough to be sent to machine translation?
So yes and no. The whole punctuation insertion, the segmenter, is the language model as such. So that's yes. Just like n-gram based, but it's not n-gram. It's longer sequences. It's a neural network based language model, and it's trained on concatenated sentences. But I think these sentences are concatenated from already a shuffled training set. So it has like these sentences became adjacent just by randomness and not by proper context. So there is a certain limitation. So that's the yes part of that. So it totally relies on some language model in the statistical sense more, and some grammatically of the sentences, no, we are not considering that at all, because well, we also do not assume that people would utter grammatically correct sentences. So that's the problem or the task that you may be referring to would be called speech reconstruction, and this is something that our department has been working on in the past as well. There the goal is to take the partly disfluent speech of myself and convert it into a written-like speech, like proper, only all correct, grammatically proper sentences. But we are not working with this component at all in our system. So quite on the contrary, we are rather moving towards machine translation systems, which would be robust to translating even these partial sentences. So I haven't mentioned it in the slides, but another students of mine, Dominik Macháček, is working on machine translation, which runs not on sentences, but on a window of words. So we would like to get rid of the segmenter altogether. And we would hopefully, if we provide it with good training data that has this property, then the translation system would be able to translate disfluent sentences into disfluent sentences usable in the target language.
Okay.
So, some more questions over there?
Okay, I have the question about the issue where to place your microphone, because several times I saw some speakers holding their microphone under their chin like this. Have you ever seen it? It's not frequent at all, but they claiming that it's completely understandable and you prevent flowing the air.
We haven't tried.
Yes.
So next time you see me giving a talk, I'll be surely holding a microphone under my chin to evaluate it properly. I don't know. I realize that there is no loudspeakers here in the room, but when you put the microphone under your chin, your voice has changed here in the wild.
Yeah.
So I don't know. Maybe the recording has not seen any change, but we have. So.
Okay.
I have two small questions. One question concerns, or it's a remark, that I think that if intonation is paid due attention to, then it might help for the segmentation a lot. Of course, in the fluent speech, people don't behave according to the rules, but still. But I have one question for your slide number 43.
I'll try to.
I just wondered, there are between, in the 34 part, you have capitals, but you don't have punctuation.
Yeah, I think this is bugs.
Okay.
So we don't know. I don't know if we can actually give it a try. If I launch this, but where is that? So here, tiny. So I'll now stop the live subtitles because it is picking the. Or I'll leave them.
I am pretty happy with your answer. So
I'm curious myself because here is the. Where is that?
Because I have one more general question.
Yeah. So please feel free to ask. I'll go to the paragraph in the meantime because. So let's switch off the Hindi and Hungarian and X1 and X0. So this is my English recognized, and it is being translated into German and into Czech.
Okay.
Yeah.
And a more general question, which maybe you have heard several times. How much can you learn or add to your considerations if you ask the translators,
the interpreters
yeah. Who have the simultaneous translation from the strategists or something like that? Is there something in the system which would reflect this experience?
Not yet, not at all. We are in touch with them because it helps us. We thanks to them we can get hold of the data, but their interpretation strategies are much more long range, so to say. So they are happy to listen to a couple of sentences even for the simultaneous translation. So simultaneous can still mean 20 seconds after that, and they will first get the whole idea and they will speak it from scratch. And this is very distant from what we are doing, but we are aiming to get into the same reign, so to say. So we have now our very first data sets where we have the source speech in English, which is being interpreted live into Czech by some of these students, and we are also transcribing the English and we are translating in the text form what was said in English. And the evaluation tool that I mentioned that will consider the quality in terms of blast score or similar scores for machine translation, the lag and the flicker, is meant, it's not yet tested, but it is meant to be applicable also to human interpreters. So ideally, we would see that the human interpreters are much better in precision or the quality of the output, but they will be much slower, they will have much longer lags, and they will obviously have no flickers, or very likely they will, well, it will be difficult to spot the flickers because the way we will be collecting the data. So, but we would really like to have automated tool that evaluates both SLT systems and interpreters in the same three scales, and then we see what are the complementary benefits of these like groups of processors. Their strategies so far are not of any use to us, and also their evaluation strategies are very distant from what we are talking about. So we have seen a checklist of when they are being graded, the interpreters. And some of these items are totally irrelevant to our technology.
Okay, thank you. So I'm afraid we have to stop at this point. So thank you again for your talk. And I just would like to announce that we don't have a session next week, and you will learn about the title and the speaker of the next following week in your emails. So thank you very much.
Okay, thank you.